In this video, we will take a closer look at dividing polynomials. We're going to take it a step further than just basic factoring. So how can we divide polynomials that may not be easily factored? There are two methods that we're going to talk about, and the first is long division. So before we get into the polynomials, I want to first review how we do long division with basic real numbers. Remember that the 672 is being divided by the 21. So the 21 comes out front of the 672. Now we can use our calculator to help us with the multiplication, but we are trying to figure out how many times does 21 go into 67, and that answer will go up top here. So 21 goes into 67 3 times, and then so we do that little division there, and then we multiply the 21 by 3 to figure out exactly how many times it goes in and what that product is. Then we subtract. 67 minus 63 is 4, and then we bring down the 2. Now we start over again. It's the same process over again, where we do 21 into 42. How many times 21 goes into 42? That answer goes up there. And in this case, it goes in twice, and it goes in evenly when we multiply, because when we subtract, we get a 0. Let's try another one. This division took a little bit longer because we were dividing by a single digit. But you can see what happens when I got down here in red. I did have a remainder of 2, but I know that if I make it a 20, 4 divides in evenly, so I went ahead and put it in a decimal. Where the decimal goes, you have to bring it straight up also, because you're not allowed to just add zeros before a decimal, but I can add as many as I want afterwards. So I put the 0 and then I brought that down. That's where I got that nice decimal answer. So with our final division problem here, the 52 into 1,872 goes in 36 times. Those are our long division. So just to summarize here again, we're doing a division into the smaller digits. Single digits are double as we go. Then we multiply and then subtract. Divide, multiply, subtract. Divide, multiply, subtract. It'll be very similar when we bring into our polynomials. So here's our first example of long division. 6x squared plus 7x plus 2 is being divided by 2x plus 1. I'm going to set it up the same way I set up the real numbers. So how we do this, because this is a binomial we're dividing by, the process is still the same. Obviously, it's just going to be a little different. So I'm interested in this first term here, 2x. How many times does 2x go into 6x squared? And that answer will go up top right here. This requires a little bit of memory from your exponent rules in the past, but 6 divided by 2 is 3, and then x squared divided by x is just x. And we check it with this multiplication here. 3x times 2x is going to give me that 6x squared, but now this is where the plus 1 comes in. I'm also going to do 3x times the positive 1 and continue that expression here with plus 3x. I am going to subtract from here. So this is where we want to make sure that we're being extra careful. I don't know if putting something in parentheses might be helpful for you. I don't know, but this is a 0, so we're just going to cross that out. 7x minus 3x, we are subtracting positive 7 minus 3 is going to give us our positive 4x. And then I can bring down this plus 2. So 4x plus 2 is now the new expression that I'm trying to turn 2x into. So the 2x goes into 2x just twice. Okay. And then multiplying the 2 times 2x to get 4x, and then the 2 times 1 to get 2. We are going to do the subtraction. And obviously if we take 4x plus 2 and subtract 4x plus 2, we're going to get 0. So this one goes in evenly, and the answer is the polynomial that's up top. This binomial, 3x plus 2, is the answer to that division problem. Let's try another one. I've set up my next division problem already with the long division. X plus 5 is being divided into this, and I'm starting with my x. How many times does x go into 4x squared? What does that x need to be multiplied by to turn it into 4x squared? And the answer is that it needs to be multiplied by 4x. I'm actually going to move the answer down here to line up with my x underneath it. So 4x times x is 4x squared. And now I'm going to go back and do the times 5. So 4x times positive 5 is going to give me the positive 20x. Now I can do the subtraction. Again, if you want to put that in parentheses, that might be helpful. So 4x squared minus 4x squared is 0. 23 minus 20 is just 3x. We can bring down the minus 16. From here, we're trying to figure out how many times x goes into 3x. What can I multiply x by to turn it into 3x? In this case, it's going to be a plus 3. Positive 3 there. Then I do that multiplication and also times the 5. And then I'm going to subtract. In this case, my 3x's will subtract out. I have negative 6 plus 15, which will give me positive 9. And this is the first time I'm going to talk about this note over here. The process stops when the degree of the remainder, that's what we have here, the degree for this constant is 0, okay? X to the 0 power, because we don't have a variable there. But the degree is 0, and it's less than the degree of the divisor up here, which is 1. Okay, so it's not always going to have to be a 0. We won't always have a constant down here. It's possible to get an x squared term down here, which we could not, we'd have to stop if that were an x cubed or an x to the 4th, because it can't be smaller than this degree here. Okay, so how I'm going to write this answer is with a fraction. The 4x plus 3 is the whole part. The 9 is positive, but it's 9 over x plus 5, just like it would be if that was a real number. We would have a fraction as the remainder. You take this bottom, what that remainder is, and you put it over top the divisor. So 4x plus 3 plus 9 over x plus 5. Sometimes you may also see the r, which hopefully you remember from elementary school division. 4x plus 3, remainder 9. I'm going to do a few more examples with you, but hopefully I'll be able to move a bit faster through them. Now on this next one, a couple things different here. The wording is x squared plus 1 a factor. In order for something to be a factor, it has to divide evenly. So I'm going to go into my division. Now what you'll notice is different here is that I have this little part here in red, and that's needed because we have a gap between the x squared and the 5. There's a gap of our first degree. And we just want to have that placeholder just in case we end up with a first degree as we go through. We want to make sure that we're not accidentally adding and subtracting everything. Sometimes it's useful, sometimes it's not. So I'm going to go ahead and get started. So this problem is now done. A couple of things happened here. When we were turning x squared into the 3x to the 4th, we need to multiply by 3x squared. When we multiply that again by the 1, we're missing this x cubed expression here. So I spaced that out simply so I don't accidentally add or subtract something to the x cubed when there are no like terms to be adding or subtracting here. So that was just something to manage as we went along. And then I forgot to bring down the 0, but it was just the 0 minus -4 is where the plus 4x came from. I did bring down the 5 just to make sure that I didn't mess that up. Positive 5 minus 9 is where the -4 comes. And though there's still a variable down here, its degree of 1 is less than this x squared, so that is the remainder. So my final answer for this problem is no, because the question was really, is it a factor of? And we'll say no because it doesn't divide evenly, or no because there is a remainder. However you want to describe that, it's just asking if it divides evenly. So this one ends up being a lot longer set up than it might look because we have a very large gap between x to the 5th and the x to the 0 constant of the -32. So I'm going to go ahead and figure out how many times x goes into x to the 5th, trying to keep track of my placement with my like terms as I go along. So this one ended up being a factor because it does divide evenly after a long division process. This next one also ended up dividing evenly. Lots of spaces in here to keep track of, in the gaps in the original problem, and then also in the gaps when we were doing that multiplication. So really just try to pay attention to that. It can get tricky, but it does end up dividing evenly. And now that you've seen me do several examples and hopefully was able to follow along, I'd like you to do these four on your own. So if you could pause the video, please. These will be expected to be turned in. So please make sure you are showing your work, either on notebook paper or using another writing app of your choice. When you are done with the problems, you may check your answers on the next screen. However, you just want to make sure that you are taking a picture, screenshot, however it is for your work, and uploading that and submitting that to this video assignment on Canvas.